Okay, it's 6, so I think should start. So you guys are back to Jorhat or at your houses now?
Sir, we still have, sir, our holidays up to tomorrow, so we'll be back.
Okay, so by tomorrow. So any one of you doing 7 semester projects in highway or related to transportation? No one?
Sir, our projects have not yet been decided. We have just only been given our groups.
Okay, okay. So how is the placement scenario in JST? So last year, what is the percentage?
Sir, we are not actually that aware of placement scenario. We do not have any ties with some specific companies which give us placement. So the students do it mostly by themselves. But this year, they are supposed to bring some campus placements.
So you are which batch? Like the first batch graduated in which year? The civil?
So the first batch was in, sir, 2020. We are the fourth batch.
Fourth batch. Okay. See, full campus is always an option. So you better tie up with JEC. So JEC, AC, because in my case also, like I was from the first batch of Test University. So at the time, since it was the first batch and the batch rank was also not that much, so many companies were reluctant to come. So we explored this full campus. So we tried to tie up with AEC, then other NITs, and it worked also. In the first batch, most of the students got like selected for campus placement. So we tried that way also. Otherwise, we keep preparing for GATE. GATE is always a safe option. Safe in the sense, if you do hard work, it will always get reflected. Unlike some other exams, okay, generally in government exams, the question paper is very unpredictable. But in GATE, if you do hard work, you'll definitely get selected. I mean, you will get some good marks. Okay, so shall I start?
Yes, sir.
All right. So yeah, today we are starting this design of flexible pavement, and can I assume that you at least know the basics, not the design, basics of the design, but like what is flexible pavement, how many layers are there. So is it okay to assume that? Did you design flexible pavement in your higher engineering course last
No,
year?
sir. No, sir.
Okay. Uh, like even with the old code you didn't design?
Sir, we had a part, but we actually skipped over it because of sir lockdown restrictions and such. The design part was not done during online classes that much.
Okay. Anyway, so we'll learn in details then. I thought maybe you are aware of the guidelines, but okay. See, there are two types of pavement. You know that, two broad types. There are many modern categories, like if you see this interlocking block pavement, ICBP, that is also like used in most of the roads, especially in urban areas and sometimes in rural roads also. So that is completely a different category. But when it comes down to two major types of pavement, we always talk about rigid pavement and flexible pavement, right? So shall we start our discussion which first discussing this, what are the advantages of flexible pavement, what are the advantages of rigid pavement? Just let's discuss. So can anybody tell me some advantages of flexible pavement over concrete pavement?
Sir, it is economical. The shock absorbing characteristics are much more better than rigid pavements.
Okay. So when you say economical, do you say the overall the life cycle cost or only the initial cost?
Sir, the initial cost.
Initial cost, because the overall cost is always less in concrete pavement. See, when you design a pavement, in our last class we like discussed that pavement is generally designed for a longer horizon, say 15 years, 20 years. So when flexible pavement is designed for 15 years, it doesn't last for 15 years without any maintenance. Okay, you need periodic maintenance. We saw that after 2 years, maybe some potholes need to be fixed. Again, maybe after 6 years, we need to like scrape off the existing layers. Then again, we need to relay only the top layers. So when you do these things, ultimately at the end of 15 years, the total cost will be much higher than the initial cost of a concrete pavement. Because concrete pavement, when it is constructed, you don't have to even maintain it for next 15-20 years. Not even a single penny has to be uh, like spent on maintenance works. But why do you think why people still go for flexible pavement? Why India is still like after flexible pavement? What is that benefit? If it has to be maintained in the total life cycle, the cost is less than, I mean, the cost is high for flexible. Then what is the reason do you think that people are still using designing flexible pavement?
Sir, I have no idea.
Okay. Anyone else? Any idea? Wild? Any random guess? বা ক'ব পাৰা যিকোনো কি ভাবা মানে কিহৰ কাৰণে মানে ইম্পৰ্টেঞ্চ বেছি দিয়া হয় ফ্লেক্সিবল পয়েন্ট? See, if we uh, think politically, a government is always like formed for 5 years typically, right? Unless it is re-elected, it is elected for only 5 years. So during 5 years of this tenure, the performance of the government is judged on the basis of the total road network length it has created. How many new roads the government has sanctioned? How many uh, roads have been newly included in the scheme, right? So, and as we know, the initial cost of flexible payment is very less. So, if we think only for 5 years, the flexible payment will last for 5 years without any problem, right? With some minor maintenance, it will definitely last, right? So, why anybody will think for 30 years? Okay, because after 30 years, that government may not be there, isn't it? So, people have the tendency to go for more number of roads, and in order to like construct more number of roads with limited budget, especially for a country like India where we don't have the luxury to spend that much amount only for roads. We have other issues to tackle with. So that's why we prefer that, okay, let's at least in our tenure, let's build some roads here and there, then we can claim that we have built this many kilometers of roads. For how many years it is going to last, that we are not worried about. Even if it lasts for 30 years, then the next government will take the credit, right? So that, as a pavement engineer, we feel is the correct or the most important factor why flexible pavement, instead of having so many stresses, is still being preferred over concrete roads in India. Okay, and uh, when we talk about the riding experience, which road gives a smooth riding experience? I think you have traveled in both type of roads, most of you. So can anybody tell me which type of roads gives the smoother experience? This,
Sir, flexible payment, sir.
yeah, why not rigid pavement?
So the flexible pavements have greater shock absorbing capacity. The friction is better in, and therefore the riding is also smooth.
Okay, so it's not about shock absorbing power basically. Flexible pavement flexes. So this smooth riding experience is not related to that factor. It, there is a term called International Roughness Index, that means how rough the pavement surface is. And in newly laid flexible pavement, if we compare with a newly laid concrete pavement, this roughness index will be lesser in case of the flexible pavement. That is one of the reasons. And the second reason is, like in concrete pavement, you will see that there will be some joints at definite intervals. Say after every 4.5 meter, there will be some joints. Why do you provide these joints? By the way, in concrete, what will happen if you don't provide the joints? As a civil engineer, what do you think? What is the reason?
So the pavement might flex too much.
uh, Say concrete shrinks, right? So whenever you mix water, cement, basically the total volume reduces, so some shrinkage will be there. So that's why we provide some crack, like cutting joints. So if you don't provide the joints, cracks will appear in random locations. So those cracks ensure that even if crack occurs, it will appear through those cut joints only. Okay, so that's why we provide joints. Anyway, because of those joints in concrete pavement, you will feel some kind of when you travel, na, if the joints spacing is too much, you will feel some unnecessary like jolts, isn't it? So that also doesn't give a very smooth, comfortable riding experience. Anyway, coming back to flexible pavement, how it is designed, there are many codes. Okay, there are many codes related to flexible pavement. Four are, these four are just uh, the most commonly used ones. This one is SP72. This is for rural roads. Rural roads, how do you classify the road is rural, the road is not rural? How do you classify? That is not based on the location of the roads, it is based on your traffic. Do you know the full form of MSA? What is MSA? MSA.
Million standard excels.
Million standard excels. Very good. So what is this million standard excels? So suppose a vehicle is there. Okay. This vehicle has how many axles? 2, right? So like that, if this vehicle goes through this road for say 5 lakhs numbers of times, 5 lakhs numbers of times, then total numbers of axles that passes through this road will be 5 lakhs into 2, right? 5 lakhs into 2 will be 10 lakhs. So that will be 1 million axles. But what is this standard? Because this vehicle can be a car. This vehicle can be a car. Another vehicle can be one truck. The old trucks have same configuration, axle configurations. One axle at the front, one axle at the back. So do you think the damage caused by this car and the damage caused by this truck will be same? No. The damage caused by this truck will be always higher. How much higher? That we will discuss in details. Okay, but just remember this million standard axles means in that total, suppose you are designing this road for 15 years. So in 15 years, how many axles will pass? Okay, how many standard axles will pass? So that count is called like standard axles. How many million axles? Say like 6 into 10 to the power 6 is the total axle counts. So we can call it directly 6 MSA. So 6 MSA means that road cannot be designed as a rural road. Okay, so that we cannot be designed as a rural road. We have to move to this category, that is your just a normal flexible pavement. Okay, so where in most of the state highways, even major district roads, national highways, expressways, the traffic will always be greater than 2 MSA. Alright, so in that case, we will focus in this course mainly on IRC 37 because IRC SP72 is very simple. Some standard thicknesses are given, so you need to just check it whether it is like enough or not. So this IRC 37, you have to master it because many questions come, especially in GATE, in interview also. Designing of road means always designing with IRC 37 because as I discussed, flexible pavement roads are almost more than 90% in India. Out of the paved roads, more than 90% roads are still made of flexible pavement. So that's why this code is very useful, and we will learn in details how to design a road with this code. Okay, but this is for new pavement. Suppose you just have the alignment, so you have to construct a road from the subgrade level, then this code is useful. Suppose a road is already there, after 5 years, 6 years, you need to simply resurface the road. Resurface means you need to scrape off the materials and you have to again put some new materials over it. Then when you put the new materials, what should be the thickness of this bituminous layers? Okay, that is found out using these codes. One is IRC 81, one is IRC 115. So similarly, like generally for high level roads, like we can say this and this and this and this. So for high level roads, like primary categories, expressways, national highways, this IRC 115 is used, and for secondary and tertiary, generally this your Winkelmann beam deflection technique IRC 81 is used. Okay. Now coming to design. So when you say designing a road, what does it basically mean? Does it mean the width of the road? Does it mean the curvature? Does it mean the thickness? What does it mean in the context of pavement engineering? What do you think designing a road means? Designing, yes?
So selection of materials and determining the thickness.
Yeah. So in the context of pavement engineering, designing a road always means you need to find out the thickness of different layers, and also you need to determine what are the materials to be used in all the layers. Just like in building, designing a building doesn't mean that you, this layman point of view, when you tell someone that I am designing a building, the person will think like that, okay, so some kind of aesthetic beauty is like attributed to the building, this how the sunset is coming, all those things. No, that is the job of an architect, not an engineer. So as an engineer, what do you design in a building? Anyone? What do you design in a building?
So the dimensions of the various columns, beams, and the structural elements.
Yeah. So the dimensions as well as the material type, whether it should be M30 grade concrete, M25 grade concrete. If you are using a steel, then whether the steel should be FA415, FA500, those things you design, right? Similarly, in case of roads also, you need to find out what should be the materials, what should be the thickness, all those things. So now can anybody help me with the bottommost layer in a flexible pavement? What will be the bottommost layer? If there are, you know that there are different layers. So what is the bottommost layer in a flexible pavement? What is it called? Anyone remembers?
Subgrids.
It's called subgrade. Okay. And mainly, what is the material used in subgrade?
Aggregate.
No. In subgrade, we use soil only. Okay. So that's why sometimes it's called soil subgrade. So if you remember, the layer is soil subgrade, then it is better, because you will be knowing that only soil is used. But this is the uh, layer that you are going to construct. But what do you call the layer which is already available? Suppose there is a rural, road connectivity from one village to another. So over that you are planning to design your road. So the first material you will put over it is a soil that you will compact. Okay, this soil will be compacted. So you will place the material over something, right? So what is that layer called? Anyone? Generally it's called embankment. Okay, so embankment is not a part of the new pavement, so it is an existing like soil layer over which you are going to construct your all the layers one by one. So this is soil subgrade. Over that, what do you have? Anyone?
The compacted subgrid.
This includes compacted natural road. Okay, the subgrade includes both. Then
Sir, subbase course.
subbase, very good. Subbase, and over that,
The
base, over that,
binder.
binder, and what is the
So surface course.
surface, or we also call it sometimes wearing course. Okay, So why do you think this we need different types of layers? Does it have anything to do with the function of layers? So which layer is the most expensive ones? Would you tell me which is the most expensive layers?
Surface coat.
Surface course, because we use bitumen. Bitumen is also called black gold because it's very costly. 1 kg of bitumen is almost 45 rupees per kg. Okay, so that's why bitumen is called costly, and that bitumen we are using here. So this, of course, a very expensive layer. Okay, okay. So then we have binder course. So in binder course also bitumen plus aggregate. In surface course also bitumen plus aggregate. In base course, what do you have? What do you think? Something inferior to this layer, bitumen plus aggregate, but superior to soil. What do you think?
So only aggregate.
Aggregate. Okay, but aggregates, don't you think it will be very like loose? It will not have. It will not be bound together. If you think about surface course, these aggregate particles are bound by this bitumen. Bitumen is a binder, isn't it? Just like concrete. In concrete, the binder is cement plus water. Cement plus water becomes a hydrated product, so it binds the aggregate together. Right. So in similarly, in bituminous mix, the bitumen is a binder that binds the aggregate particles together. Okay. So what do you think? What material will bind these aggregate particles here in base as well as in substrate?
So soil.
Soil. So I will ask a question now. Then. Is sand an aggregate? As a civil engineer, what do you think? Can we call
Yes, sir.
sand an aggregate? So what type of aggregate it is?
So fine aggregate.
Fine aggregate. Okay. So now I tell you that both coarse and fine aggregate will be there as well as here. So sand and this bigger size of aggregates both are there. So still, do you think we need some materials? We need some binder to bind this together. I think you already know the answer, but you are not able to relate. Have you heard of this term WBM?
Waterborne macadam.
Water-bound macadam. Now think in this manner. Water-bound macadam. So what is the binding material here? Bind,
The water.
bind, bound, right? So it is bound by water. So water is the binding material. So in presence of water, it will be sticky. So can be compacted to a very high density, and that's why we call it water-bound macadam. So this is generally we use WBM. Nowadays WMM is used, wet mix macadam, but in either case water is the binding material. So yes, water can be called a binding material in case of this base course. In sub-base course, we use GSB, granular sub-base. That is when you go to field and you join any company, any organization that constructs roads, you will like hear these terms very often. WBM, CSB. Okay, so this WBM stands for waterborne macadam, and this CSB stands for granular subbase. Now, if I say that this is also bitumen plus aggregate, this is also bitumen plus aggregate, first two layers, then why we need two different layers? Can we simply construct one layer like this? This is also like fine aggregate, coarse aggregate plus your water. This subbase also fine aggregate, coarse aggregate plus water. So can we construct as a single layer? What will be the problem? Just think. Can you consider? See, in flexible pavement, what happens? The load is passed through aggregate to aggregate contact, right? So aggregates will be there like this. So the loads will be passed. If a vehicle comes at the top, suppose this is a wheel, okay, this vehicle has come, so this load will be distributed like this. So what this distribution means, because this aggregate will be supported by two aggregates from its bottom, right? And again this aggregates will be supported by two, this will be supported by two. So whatever load comes, it will get distributed, right, like this. So if it gets distributed, that means the area will be more. So if my area is suppose 1 meter square, and I apply a load of say uh, 20 kilonewton, and if my area is say 10 meter square and I apply the same load 20 kilonewton, so where stress will be more, the case 1 or case 2?
This one.
Case 1, because stress is basically force by area. So since the area is increasing because of this contact of the aggregate particles, the area is increasing when we go down. Okay, so what do you think? The stress here, if I take a point here and if I take a point here, where stress will be higher? Here or here? 1 or 2?
So 2.
Why? Anyone else?
So no, sir. It was my mistake. It's actually 1, sir, because
One.
yes, sir,
Area
because the area is much smaller.
area is smaller here. So similar, just like this example. Okay, area is smaller here. So the same load, area is smaller than this one. So here stress will be more. Suppose I call this sigma 1. It's my stress at this point, and at this point my stress is sigma 2. Okay. Now, in any kind of design, let it be building design, let it be road design, let it be even some mechanical design, as an engineer, what we have to ensure? That something doesn't fail. To ensure that something doesn't fail, what do we have to ensure? If I say that so if I have a concrete cube, okay, if I have a concrete cube, you must have done this test, right? Test of concrete cubes. You prepare concrete cubes, you apply load, right? So you are increasing the stress basically, right? So when it will fail and when it will not fail, anyone can?
Sir, the load must not exceed the compressive strength of the tube.
Yeah. So the point I am looking at is strength. So the stress should not exceed the strength of the material, right? So in order to ensure that this at this point the material doesn't fail, we need to ensure that the strength of this material is higher than the stress at this point, or the strength of the material here or anywhere is higher than the stress at this point. Do you agree? All of you agree with me, right?
Yes, sir.
So when you agree with me, so will it be economical if I simply construct a very huge bituminous mix without because as I know that the strength of my first layer is, is the best, because we are using the most costliest material, bitumen, to bind the aggregates. It will have a very high strength, right? So is it like an economical, will it be like economical to provide these materials throughout the entire pavement? No.
No, sir.
Why no? Because we
Sir,
know that, yeah, tell.
because sir, the bottom layers do not require that much strength.
Yes, the bottom layers do not require that much strength. So that's why these terms, sub base, it is a base layer only, but sub means always what? Some inferior, right? Something, if you write sub along with it, it will be, it will be inferior. So it is a base course, but we are using inferior materials compared to base, just to cut the cost. Okay, just to cut the cost, we are using inferior materials in surface. Surface course and binder course, we are using bitumen plus aggregate only in both the mix, both the layers. But the uh, kind of quality of this bituminous mix that we use in the surface course will be superior to the binder course. Why? Because we don't need that much of strength in the lower layers, because stress is distributed, and because of this distribution, high area, the stress is lower, and in order to tackle that lower stress, we don't need higher strength. So you understand the basic concept, why
Yes, sir.
we need different layers of different quality. Okay, soil has the, like, out of all this, you agree that soil has the most inferior strength, right, compared to aggregates, compared to bitumen plus aggregate, all those things. So I think you understand. So this is anyway, I will share the slides. So, like, see, this range is, you will see in many examples that some values will be written like that, wearing force should be from this to this, from this to this. So these are just, some guidelines to guide you, to give you an idea that generally wearing force is in between this. But as an engineer, you have to find out the exact thickness. Okay, because if you increase the thickness from 27 mm to say 30 mm, only 3 mm you have increased, but 3 mm increase will be throughout that 100 kilometer of road. So can you imagine how much of total volume you are increasing in the total, the entire, if you consider the entire road. So 3 mm into 100 kilometer, you can find out what will be the volume. And if you can convert it to some, like, the cost of the material per unit volume, then you can find out how much will be the total cost you have increased. So do you think your company will allow you to do that? No, they want the road to be performing well as they want to cut down the cost also. So whatever at the optimum thickness that you can arrive with proper design, that you should be having. It should not be like that. You design a road and you give higher thicknesses. Nobody gives higher thickness anyway. They will always lower the thickness. Okay, because lowering the thickness will give them some extra money, isn't it? So that's where corruption begins and all those things. Anyway, uh, there are some other layers also, like seal coat, prime coat, and tech coat. So are you aware of this? What is seal coat, tech coat?
Yes, sir.
No. How to remove? Okay, so this seal coat is applied on the top when the final layer is applied. It is applied at top. So it's basically a mixture of bitumen, emulsion, and sand. So just it is sprayed on the top. You must have seen some kind of spray at the bottom of the truck, like uh, at the backside of the truck. It is sprayed. So this is seal coat. Sometimes it's sprayed with, you know, with some sprayer also. So this seal coat, as the name suggests, it will seal the pavement. Okay, it will seal the pavement because sealing it is very important. Otherwise, if water percolates through the pavement, then it will be a problem. Say these aggregates are now bound by bitumen. Okay, we have used bitumen to simply keep the aggregates in place, right? But when water comes in contact with this mix, in cement contact it's the other way around. We need water to come. For which reaction, for which mechanism? Why do you need water in cement contact? Come on, as a civil engineer.
Sir, for setting of this,
Yeah, the process is called hydration.
right?
Hydration, because it will lead to the hydration of cement. But anyway, but in case of bituminous mix, it's the other way around. These aggregates, these aggregates, they are coated with bitumen, right? Coated with bitumen, and they are together. So when water comes, generally these aggregates are called hydrophilic. Any idea what hydrophilic means?
So attracted to water molecules.
Yes. So you know that fill, this word fill means attraction, and what is the opposite of this philic?
Phobic.
Phobic. So if I say hydrophobic, it means it it like hates water. But philic means it loves water. So this aggregate loves water. Okay, but like forcefully it is married with this bitumen. Okay, now when this water comes, this aggregate will, since it loves water, it will have the tendency to get attracted to this water, and because of this bitumen coating comes out. Okay, the bitumen coating comes out, and when bitumen coating comes out, we discussed in our last class what happens. What happens when bitumen coating comes out? The aggregates are no more bound. They are no more bound. Bitumen is the binder, which was binding the aggregates in place, right? When this bitumen coating itself is not there, the aggregate will be loose. So whenever some vehicle comes, the aggregate will come out here and there. And like that, what is created?
Potholes.
Potholes. Very good. So, uh, that's the reason why we want to seal it. So when we seal it, and I think you know the basic terms like camber. Camber is the cross-slope which is provided, to drain out the water, rainwater. So when rainwater comes, it should go this way, right? And if you don't provide seal coat, it will penetrate and it will be there, right? So this is seal coat. This is tack coat. Tack coat is in between the binder course and the wearing course. So both are bituminous mix. So then why do you think there should be some layer in between? Why do you think so? I will give you a hint. This tack coat is not needed to be provided if we construct this wearing course like within 24 hours of construction of this binder course. Then we should not provide tack coat. But if the time difference of construction of this binder course and this wearing course is more than 24 hours, then we need to provide. Now,
Sir, for better adhesion, sir.
yes, for better bonding. Otherwise, if time, maybe after 24 or during that 24 hours, or maybe after that, so because in state government departments things run very slowly, so they will lay the layer, they will forget, and again after 1 month the budget will come, they will now lay the next layer. Suppose there is no adhesion because it has pulled down, okay, and again a new layer has been formed. Now there is no adhesion. This tech coat is basically a glue. So it's not a glue, it's bitumen emulsion only. So this acts as a glue to like have some proper bonding between these two layers. Now anyone will like to answer except Kosik. Kosik and Midupaman are answering most of the questions. What about the rest? Are you getting what I'm like teaching? Anyone? I don't want to like take names, otherwise we'll start living. Anyone? Are you getting what I'm? Ankur, okay. Others? Because are you getting?
Yes, sir.
See,
Yes,
I
sir.
understand. I understand. Many people are introvert. They don't like to communicate. That's completely okay. I don't mind it. Uh, but once you have already opened up, so can you tell me any reason why there should be proper bonding between the layers? If there is no bonding, what can happen? Anything. This is a discussion class. Vidisha, what do you think? If there is no bonding between the layers, what can happen? Devasis, Ankur. Okay. Kosik, Midugoban, what do you think? If there is no bonding between the layers? Because load,
So,
tell,
so there can be bleeding of materials.
bleeding. Okay. Mm, no, no
Sir,
bleeding.
the wearing course might slip off of the binder course.
Uh, correct. But why? Right. Load is always coming from the vertical direction. It's coming from the top. So if these two layers are like this, it is coming from the top like that. Are you able to see me?
Yes, sir.
So then why do you need bonding?
Sir, when the vehicles travel through the road, there is always usually a pullback force due to the friction of the vehicle. Also, when
Okay.
sometimes vehicles brake harshly, then there
Yes.
may be also
That's
lateral forces.
very good. So especially near the junctions, suppose there is a traffic point where vehicle will always apply brakes in those junctions. So when vehicle apply brakes, so this is suppose my first layer. So this is my vehicle. It is going like this. It is applied brake. So if there is no bonding with the bottommost layer, I mean the bottom layer, the top layer will try to move like this, right? So when it moves like this, what can happen? If it moves like this,
Sir, the wearing course might get damaged.
yeah, it may get damaged. So we learn these things in details when you learn this rehabilitation of pavements, but it's called soveling or sometimes corrugation. So some wave sort of things. Okay, you will see this is where the brake has been applied. This is where the brake has been applied. That's why it has the layer will look like this. Okay, understood? So designing a pavement means determining the thickness of different layers, and the exact thickness of the layers needs to be determined to optimize the cost and minimize the future stresses. Till now everything is clear.
Yes, sir.
Okay.
Yes, sir.
See, don't take this class as your normal routine class. You have enrolled this course just to learn something new, isn't it? So you will learn. If you have any kind of doubt that comes to your mind, feel free to ask. Okay, there is no silly doubt. Every doubt is very genuine. So don't hesitate. You can ask any question related to what in this course. Okay? Any random thought that comes to your mind. Okay. So these are some of the common distresses in flexible pavement. There are many distresses. Okay, but when we design a pavement, we design it mainly to tackle these two. One is called fatigue cracking, one is called rutting. So this fatigue cracking, what do you mean by fatigue?
Sir, cracking due to
No,
repetitive strain.
I am not talking about uh, scientific meaning. Literally, what does fatigue means in English, in French?
Sir, tiredness.
Tiredness. So anything when it gets tired, you can like tell that my body is in fatigue. That means you are tired. When you get tired, when you
Sir,
do
when
something, yeah,
so when effort is like you give your
yeah,
effort.
yeah, relentlessly you are working and working, you get tired, right? Just like that, when the pavement gets tired, it cracks in fatigue. Okay, how pavement will get tired? Suppose I give you an aggregate. Okay, an aggregate I have given you. I have asked you to break it. Yeah, I asked you to break it. Forget about aggregate. Let's say this is a mouse. I have asked you to break this mouse. So what are the options you have? How will you break it?
Sir, using impact force.
You can apply impact force. You can get an hammer. You can apply force like this. This mouse will get broken. What are the other options?
Sustaining.
You can apply force gradually. You can increase the force gradually like that, and ultimately it will get crushed. Right? That is one of the ways. Any other ways? Any other ways? See, that's why this fatigue is important. Fatigue means when something is tired. That means suppose if I like try to uh, so make this mouse like try to bring suppose this mouse is flexible, little bit of flexible in nature. So if I apply some load repeatedly like this, will it fail? Will it fail?
Yes, sir.
When will it fail? How many strokes do I have to apply to fail, to crush this, to break this?
So it depends upon, sir, the manufacturing process and the life up to
Yes,
which it has been manufactured.
yes, but generally millions of times. Okay, so if I strike it millions of times, then it will get tired because of this repeated. It is deforming, it's recovering like that. It will get tired and ultimately it will fail. So breezes also fails in fatigue, right? So breezes when vehicle moves, it will be like this, ultimately it will fail. Similarly, roads also fail in fatigue because we know flexible pavements flexes. Flexible means it flexes, right? It bends. So when vehicle comes over it, the layers, this is my layer, when vehicle moves over it, it will bend. Then when the vehicle goes, it will again recover, bends, recover. So when it recovers and bends like this layer will get tired. And when it gets tired, cracks will appear. So that's what called fatigue cracking. Okay, rutting. What do you think? Why this rutting is appearing here? This is called rutting. Okay, along the wheel path, vehicle is moving, and you can see some depression. So I draw the cross section view. It will be like this. Why do you think it will happen?
So due to some relative deformation of one part of the road.
But what can be the fault in that road because of that it is happening? One will learn. Okay, will learn. So this fatigue cracking is a failure which results from repetitive action of loads. That means you are applying repetitively the same load again and again and again, and ultimately you will see some hairline cracks. Minor hairline cracks will appear. It starts initiation will be always with some hairline cracks. You understand the difference between hairline cracks and structural cracks, right? In wall plaster also you see some cracks will be very minute. Okay, so these are hairline cracks, and but these microscopic hairline cracks will get developed into some wider microscopic cracks. Microscopic cracks means you can see with your naked eye. You don't have to see with a microscope. You will see with your naked eye. Much wider cracks will be formed. Then these wider cracks will coalesce, means it will like get interconnected with each other, and they will form a network of cracks. And this network of cracks, it looks like the back of an alligator or crocodile. So in many textbooks you will see this term also, alligator cracking. Alligator cracking. And rarely in some other textbooks you will see crocodile cracking also. Crocodile cracking. Mainly alligator cracking is a very frequently used terms for fatigue cracking. Okay, so have you understood what fatigue cracking is?
Yes, sir.
Right? Okay. Now the causes can be like many. Mainly when some decrease in the pavement load supporting characteristics, because these are the layers, and suppose uh, this entire system is acting in a very good fashion, then it will not fail. But because it is getting flexed and it is recovering, and if these layers are good enough, then it will not flex much, right? But if these layers are soft, then it will flex much higher, like this. Or even if these materials are soft enough, then also it will flex too much. So when it flexes too much and it is recovering again, just like that, again it will be like this. So where do you think the cracks will appear first? At the top or at the bottom?
So at the top.
At the top. Why?
So because the pressure at the top is much higher.
No, it is not. See, that is the difference between fatigue crack and cracks which are because of formed because of higher loads. Both are cracks, but fatigue cracks are because of getting tired. So if I take this, okay, this is my layer. If it is getting like this, like this, like this. So ultimately, at one point, some cracks will appear. Where do you think the cracks will appear? Here or here? If you see,
So the bottom.
some cracks have already appeared, right? So it will appear at the bottom. Okay, it will appear at the bottom, and it will travel, and it will appear at the top. Travel, it will appear at the top. So you suppose you have seen cracks, okay, in the road surface. Now in order to understand why this crack has appeared, what you will do? Suppose there is a crack, this top section here. You are being called as an engineer. Please come, see, cracks have appeared. What can be the reason? How will you tell? You will simply take a code. Okay? You simply take a code. This is the top view, and because these are the cracks. you will simply take a core. Core means, with a core cutter, you take a core and you take out the core. So this is the core, suppose. So if you see that the crack is from the top, from the bottom, okay, and it's going to the top, then it is mainly due to fatigue. And if you see that it is coming from the top and it is not touching the bottom, then it is mainly due to higher load. The load is higher. Okay, so in fatigue cracking, because we cannot like design a load for higher loads, because we have already given information that overloading is a crime. The vehicles carrying overload should be charged, right? So we cannot design for higher loads. Okay, so with some standard loads, with some maximum legal axle load, we will design our loads, right? So if now if we, by looking at a crack, you can tell whether overloading is being done on that road or not, whether it is because of the natural phenomena of fatigue or because due to overloading. Have you understood this phenomena of fatigue cracking?
Yes, sir.
Okay, so now why this fatigue cracking will happen? Have you ever done any experiments on bitumen, related to bitumen?
No, sir.
We have never seen bitumen.
So we have seen bitumen, and we have been given some demonstrations, but
Okay,
we have never done it on our own.
okay, but you have an idea how bitumen behaves, right?
Yes, sir.
So how bitumen behaves? Is it a solid? Is it a liquid? Is it a semi-solid? How it behaves?
It's a semi-solid, sir.
Semi-solid. Like at which step? At what temperature it will be semi-solid?
Sir, higher the room temperature, like 60 to 70 degrees.
Hmm. If I heat the bitumen to say 150 degrees centigrade, will it be semi-solid?
Yes, sir.
No, it will be liquid. It will be like water. It will flow like water. You can simply flow. Simply like pour bitumen, you can like spread it like anything. Okay, so that's why bitumen, when it is mixed with aggregate, we heat the bitumen to say 150, 160 degrees centigrade so that it becomes like water. Okay, it will be very, very less viscous. Then if we simply, mix the aggregates, play, uh, like the aggregates, mix it, then with time the temperature will reduce and ultimately it will become solid again. Then the bitumen, the aggregate particles and the bitumen together, the bituminous mix will be very in a very solid state. Okay, so that bitumen is basically very complex. Okay, the bitumen, uh, I thought you will be knowing much about bitumen, but since you don't know, I think I will take some extra classes on this bitumen thing. What are the different tests, penetration, softening point, what it signifies. So I will take a different class. But remember one thing, that with time this bitumen will get hardened. It's not about which temperature. With temperature, of course, if the temperature is lowered, the bitumen will be solid. If the temperature is higher, bitumen will be liquid. I am not talking about that. With time, that means you have the same bitumen is now, but suppose you have used in the road. I am talking about after 5 years, after 10 years. That bitumen will be in the like always under the constant exposure of sunlight, and because of that, this bitumen. How do you get bitumen? How do you get bitumen? From where do you get bitumen? Any idea?
So from coal.
So asphalt.
From asphalt. Okay.
So from coal.
From coal. Any other gases? Okay. This
So
is
from petroleum, I think.
from petroleum, yes. So from petroleum, you get petrol, diesel, kerosene, naphtha, and the last product, which have the highest molecular weight or boiling point, is bitumen. So from the same petroleum, you are getting petrol, diesel, kerosene, and also bitumen. Okay. So petroleum is a hydrocarbon, right? So it's a mixture of hydrocarbons. So there will be different hydrocarbons. I will not go into details because since you don't have the basic idea of bitumen, I will discuss these things later. But with time, it will get hardened because it is under the exposure of sunlight. So this volatile will, evaporate thing, and it will be brittle. So that's why you conduct this ductility test. You stretch the bitumen. You test whether it is brittle or ductile. So in phase step, it should be very much ductile. With time, after 5 years, it will test the same bitumen. It will fail in ductility because it has become brittle. Okay. Anyway, not going into that. But I will come to that later. Okay. These are again some advanced things. I thought I'll cover this, but let's not discuss. But yeah, coming back to rutting now. I think fatigue cracking you have understood. So this bitumen, why did I discuss about this brittleness of the bitumen? So if the bitumen becomes brittle, when it flexes, it will crack easily, right? So with time, it will anyway fail in fatigue. So fatigue cracking, it cannot prevent. It will anyway fail, but we can delay it by using good bitumen. Mixed proportion should be good. Okay, testing the bitumen before. So by doing that, we can simply delay it, at least to the design life. Okay, but we cannot prevent. It will ultimately fail in fatigue. Okay, I can give you this example. You all have your these buckets. The buckets you use at your home is made of plastic, right? So these buckets, when it is newly procured, you can take water and you can carry much water with those buckets without having the fear of failing, right? It will not break. But when you keep the bucket, outside under the exposure of sunlight, say for after 1 year, 2 years, what will happen?
So the material isn't as malleable, so it becomes
uh,
like brittle.
it becomes, the material becomes brittle. If you overweight, it will get cracked. It gets cracked easily. Why? Why do you think? What has changed? What has changed? So this plastic, so some molecules which like keeps the ability to bend, flex to this plastic, it will get evaporated under the sunlight, and because of that, the plastic will become very much brittle. And that's why it breaks after 1 year, 2 years. But that's also called kind of fatigue only. Okay. Anyway, coming back to rutting. So why do you think this kind of depression should form? See, this kind of depression can occur mainly because of two problems. One is like there is a problem in the mix and there is a problem in the substrate. So substrate, which layer is substrate? This is surface, binder, then base, then sub base. Okay, never put sub base over base because sub means inferior, so inferior material will be always at the bottom. Then comes your subgrade. So if there is a problem in the subgrade, that means the soil is not good enough. Then if you overload or with some heavy load is passing, then it will be like this, right? It's kind of problem will occur, right? And also, if the suppose the material soil is good, it has a very good strength, but if it has not been compacted well, that means the rollers are not passed significantly, it has not been compacted by the rollers well, then it will be, the density will be lower initially, but with passage of time we get these depressions will be formed. Do you agree?
Yes.
Okay, so but it can be like this also, that the subgrade is good enough, the subgrade is good, the problem was in the mix only, everything is good, the topmost layer is not good, then also it will be like this. Okay, then also it will be, you can like see problems like this. How will you differentiate as an engineer when you go to site if you see problems like this? So if you see the site view, if you see that this material, okay, this material is like heaved, okay, this is heaved, that means when the vehicle load wheel is coming, this material is sheared off like this material has to go somewhere, right? So if it is sheared off like this and some hips are present on both the sides, like here you can see here some hips are there, right? So then it is a case of problem in rutting due to the mix. But if the problem is in the subgrade, then you will not see any kind of shear, it will be like this. Okay, it will be like this because it will be like coming from the bottom. But you have understood rutting, right? What is the main problem? Mainly because of the problems in the subgrade. So you should check whether the subgrade is good enough. These are some causes in rutting. So now, since you already know what is fatigue, what is rutting, now can anybody tell me what are the critical positions in a pavement where you need to check for fatigue and rutting? So this is my surface course. This is my anyone can help me with the names? I forgot. What are the other names of the other layers?
Surface course, binder course, or
No,
base course?
not course. You already answered that. Anyone else?
So base,
No. After surface,
binder,
very good. After binder, nemesis. It will be the next layer.
Base.
Base. Very good. Okay, Vidisha, what will be the next layer after base?
Sub-base.
Sub-base. Very good. Then
Subgrade.
subgrade. See, you are paying attention. I thought most of the people are simply have joined and they are doing household works. It's not like that. Good. So now, what are the critical positions when you need to check for rutting, fatigue? Say these are bitumen. Okay, these two are bitumen, and we know that tech coat is there, so we can consider this as a single layer. Okay, this is the bituminous mix. Okay, the bituminous. This also we can consider as a single layer because that is basically aggregate plus water. Okay. Okay. This is again a different layer, which is soil. So I have simplified this many layers into only 3 layers: bituminous, aggregate, and soil. Bituminous, aggregate, soil. So now the load is coming here. So where fatigue cracking would occur?
So bituminous.
Bituminous mix where? At the top of the bituminous mix, at the middle portion, at the bottom, where?
So bottom.
Yes, at the bottom. We discussed it, right? Like this here. So here we need to check for fatigue. Okay. If it passes this fatigue test at this depth, which the depth is 200. So at this depth, if it passes, then here you don't have to worry. Okay. What about subgrade? Sorry, what about rutting? Where do you need to check?
Subgrade, sir.
Subgrade. At the top of the subgrade. Here you need to check rutting. So because here the stress will be again less. So at least here the stress is higher than this point. Right. So if it passes here, you don't have to worry about the lower points. You need to check rutting at the so fatigue, where you need to check bottom up what?
So binder course or
Bottom up binder course, or we can say bottom up bituminous mix. Okay. And rutting where?
top of the subgrade.
Top of the subgrade. Very, very good. So you are all set to design the road. See, in building also, why do you draw this bending moment diagram, shear force diagram? Why do you draw?
So to determine the critical positions of failure.
Yes, determine the critical positions. So that means if the bending moment diagram is like this, that means you know that the moment is maximum at the middle. That means if a simply supported load is there, and if there is a possibility of failing in bending is maximum at the middle, right? Similarly, shear force diagram will be like this, right? So the possibility of failing in shear is maximum near the edges, right?
Yes.
That's why we draw this. So similarly, we don't have to draw here. It is very, very obvious that fatigue, or in like in terms of fatigue, the critical position is here, and in terms of rutting, the critical position is here. Okay, can we move forward?
Yes, sir.
Okay, so this IRC 37, okay, IRC 37 has given many design catalogs. Design catalog means what? See, now technology has advanced, right? So we need advanced loads. Advanced load means this. If we use aggregate here, simply bituminous mix here and soil here, that road is not able to carry higher loads. And if we want them to carry higher loads, then the thickness will be very, very high. Okay, like this big will be the thickness. Then the problem is we need more materials. But do you have more materials left in art? No. Hills are being cut. Quarrying is there. Quarrying is going on. But in many states, we will say quarrying is banned. You know what is quarrying, right? What is quarrying? What is quarrying? Getting the aggregates from those hills, you use the blasting process, right? You have never visited any crusher plant. internships and during internships what কৰিছা internship তোমালোকে
স্যাৰ PhD কৰা হৈছে স্যাৰ আৰু বেলেগ এটা গ্ৰুপ স্যাৰ ৰেলৱেত কৰিছে
অকল দুটা গ্ৰুপ নেকি
স্যাৰ আৰু গ্ৰুপ আছে স্যাৰ মেইনলি আমি স্যাৰ PhD ৰেলৱেত কৰিছো আৰু স্যাৰ PWD বিল্ডিংছ PWD ৰোডছত কৰা হৈছে
see that is the problem when I was in ASA I also used to tell the students that don't do internship in government organizations is getting afforded but it's true কিমান কাম কৰে তোমালোকৰ জানা so internship সদায় প্ৰাইভেটত কৰিব লাগে তেতিয়া তুমি কাম শিকিব বহুত পাবা তোমাৰ ব্ৰেণ্ডটো ঠিক আছে ব্ৰেণ্ডৰ কাৰণে কৰিলা internship PWD কৰিছো একো কাম নাই সেই চাৰ্টিফিকেট ইজ নো ভেলু ক'তোতে তোমাৰ সেই চাৰ্টিফিকেটখন চাই কিনে তোমাক PWD নলয় বা ক'তো বেলেগ জেগাত নলয় internship কৰা হয় just to gain experience so experience পাবৰ কাৰণে you should do internship in private companies Camon Pulsloyd this kind of private companies if you do then only you'll see how engineering is going on in the real field okay but anyway this squaring and all generally learned during internship process when you visit some company they will take you from where they are getting the aggregates these aggregates they get from by blasting this huge hills you see near Khanapara for Aparasam I don't know where those kind of hills are there so those hills are blasted using dynamite you will get big cobbles then they are broken down using crushers into small sizes so you get gravels right so then again gravels to different sizes so basically the squaring is banned in many regions Andaman and Nicobar island they don't have any natural aggregate if they need aggregates they need to come to mainland India in ship aggregates are dumped then they will transport the aggregates to Andaman then they will construct roads so can they afford this much of use thickness of layers no they cannot afford so they will have to come with some smart ways that means we need strength right for strength we are giving this much higher thickness but if we can provide same strength with lesser thickness by using some additives means some strength improvement techniques like what like using cement treated base it's called CTB cement treated base what is CTSB
cement treated subbase
then with the addition of cement the strength properties has increased okay so we can provide comparatively lower thickness and still can get high performance okay so earlier in the earlier codes of IRC 37 especially the ones like 2001 2012 this kind of innovations were not there so people didn't have contractors they didn't go for this kind of different techniques by providing cement treated base cement treated subbase all those things so similarly the other catalog is like you can provide soil subbase here cement treated subbase cement treated base okay so this granular crack relief layer so why this crack relief layer is there here you can see SAMI means stress absorbing membrane interlayer so why this crack relief layer is there see because it is cement if you mix cement with anything it will be too much rigid so when it becomes too much rigid there will be chance that some cracks may get formed so when this cracks is there so even if the bituminous mix is good enough if some cracks are formed here it will reflect in the bitumen layer also. Okay, so that's why we need some layer in between where we simply put some aggregates, so that will relieve the cracks. So if the cracks are coming and this layer is only some aggregates are placed, so this layer, this crack cannot propagate to this bituminous layers. So that's why it's called crack relief layer. Similarly, stress absorbing membrane. So the stress is absorbed here. Okay, so this is like some modification over this traditional one. We will design our pavement mainly with this one because this is the most typical, pavement uh, layers which is used in most of the cases, especially in Assam. Till now, this kind of catalogs are not being used. Mainly, this catalog is used, and similarly, we can go for cemented subbase, but instead of you know cemented base, we can use some bituminous, bituminous stabilized material. That means sometimes when these layers are milled. Okay, suppose this is some potholes are there and everything. After 5 years, you need to rehabilitate the existing pavement. So you are left with two options. Either you can simply overlay without doing anything to this layer, which is not suggested because first you need to fill everything. Otherwise, if some cracks are already there, you simply overlay with new layer. These existing cracks will get reflected. Okay, these cracks are called reflection cracks. So the new layer will also get deteriorate faster. Okay, so the suggested method is you mill. Okay, you mill the existing layer, scrap with some scrapping machine. You scrap it. This scrapped material is called wrap. Okay, this material is called wrap, reclaimed asphalt pavement, that you can again reuse either in granular this here between us, or sometimes with some techniques with the new mix also you can mix. Okay, so that is also, like, if you are doing it in that way, then how to design, that is also given in your IC37 code. Similarly, GSB is there as it is, only basis change to symmetric base, but here CTSB, but this is granular base only. So these are the main six design catalogs. So mostly you have to select any one from these six options. Okay, either this first one, A, B, C, D, E, F. Okay, so based on the situation, what is the situation? If you have like sufficient amount of aggregates or not. If in Andaman Nicobar, can you go for this kind of? Can you choose A always? No, you don't have the luxury of getting this much thicker layers. You need to reduce the thickness, so they will prefer this. Okay, or this. And similarly, if you are milling the material and you want to reuse the material, then you can select C, D, like E, F, based on the situation, how much material you are left. Okay, so once you select which catalog you are going to use, you have to now design the thicknesses of different layers, like this. What should be the thickness of all these layers? Okay, but if you have noticed, can you see some red arrows in all the cases?
Yes, sir.
This red arrows means what? What does this red arrows means? This is the typical position. We learned in the first case. This is the one that we are discussing since 1 hour. This case A, subgrade soil, granular subbase, aggregate, granular base, aggregate, then bituminous layers. So here you see the critical positions are at the bottom of the bituminous mix and at the top of the soil sample. Okay,
Yes.
and mainly this kind of failure occurs where the wheels are present. Okay, so we can check different points that we learn when we use the software CANPAS. How this at different points we can find out the strain and stress values. But a critical point is depth. It is at this depth and at this depth. Here you see, along with this and this, you can see in between also this here we need to check for fatigue because this is cement treated, right? You can check here also. You can check because it's cement treated. When you mix cement, it becomes material becomes stiff, so there is a chance that stiff material will fail in fatigue quickly, right? So it doesn't, it cannot flex very easily, conveniently, so it will fail. Understood? So here also you can see here additionally. Similarly here, only here. Here CTB is there, so additionally here, here, and here. You can check here also. Okay. Understood this design catalogs?
Yes.
Yes, sir.
Okay. So IRC, as you can see, the most commonly used flexible pavement structure is catalog A. That means subbase we will solve a numerical from starting to end in for this catalog only, catalog A. So generally dual wheel means you can see nowadays single wheel trucks are not used mainly. I am drawing the back view or front view. So on both the sides there will be two wheels like this. Single wheel trucks are very rare nowadays. Okay? Very old trucks will be single wheel. Otherwise most of the trucks will have two wheels on either side of the axle. So this is called axle. This is called axle. This is called axle. Okay. It's called axle, and these are called wheels. So dual wheels. Okay, dual wheels. So I think you have not learned tandem axle, tridem axles, those terms as well, right?
No, sir.
So single axle basically means, so when we talk about axles now, we never talk about this front axle, because generally if you see, if a truck is there like this, okay, the truck is there like this, it will carry the loads mainly on its back. So if the total load of this entire truck is say P, then only P by 3 will come to its front axle and 2/3 of P will come to its rear axle. Okay, so that's why two wheels are there at the rear side and only like single wheels are present on the front side. Okay, and when we talk single axle, when you say single axle, it doesn't mean like a vehicle with only one axle. Axle you understood, na? This is called axle. So can anybody give me an example of a vehicle with only one axle?
So an auto rickshaw.
Auto rickshaw, at least one wheel is there to take the load. Think.
Motorcycles.
Motorcycle also have two wheels, na? So like we can say consider this as Excel, then two Excels, one here, one here. Excel is not like this. Excel is always like this. ভাবা আরে তো আনসাৰ দিব পাৰিব লাগিছিলে লিষ্ট অসমৰ হৈ কেনে এনি আদাৰ
Sir, pull card.
কি কয় অসমীয়াত
Hella.
খেলা খেলা is an example of single Excel created, but that is not single Excel. That's what I am trying to say. Don't get confused. Okay, single Excel, when we talk single Excel, we don't consider the front Excel. Front Excel to থাকিবই যদি বেক সাইডৰ অকল এডাল এক্সেল আছে তেতিয়া কয় সিঙ্গেল এক্সেল, আৰু যদি বেছি আছে তেতিয়া দুডাল থাকিলে ক'ব টেন্ডেম, তিনিডাল থাকিলে ক'ব ট্ৰাইডেম। অ'কে, দেখিছেনে পিছফালে জাষ্ট সেই এনেকুৱা এনেকুৱা টাইপৰ দেখিছেনে নাই? এনেকুৱা গাড়ী য'ত দুটা একেলগে থাকে,
Yes, sir.
ৰাইট? অ'কে, কিয় দিয়ে বাৰু?
Sir, ট্ৰাকৰ টো sir front মানে মাজৰ যোনটো এক্সেল থাকে এইটো অলপ উঠি থাকে, যেতিয়া লোড বেছি হৈ যায় তেতিয়া অট'মেটিক নামি আহে বেলেঞ্চ কৰিব কাৰণে।
অ'কে, কিয় কিয় সেইটো থাকিলে মানে ট্ৰাকখন ভাঙি পৰিব নেকি? নাথাকিলে
Sir, এইটো road damage টো কমাই দিয়ে because
Yes.
the load is not evenly distributed.
yes, so now the load is distributed. If I see the top view like this, so compared to base, here the load is distributed in 12 wheels if there are 3 axles. Okay, 3 axles at the end. Okay, load is distributed into 1 2 3 4 5 6 7 8 like that. 12 wheels are there. So whatever this p by 2/3 of p now, it will again get divided by 12. So that's why single axle trucks will cause maximum damage, and tridem axle trucks, even though it is highly overloaded, it will not cause that much damage to the road. Understood this concept of axles and wheel configurations?
Yes, sir.
Yes, sir.
Okay. Okay, so in IC design, this fatigue cracking and rutting is considered. So I have shown you have already learned these things. Okay, so as I said, we need to check at the bottom of the bituminous layers and at the top of the soil substrate. So at the bottom of the bituminous layers, it fails like this, right? Fatigue means it will be the strain will be in the radial direction, right, like this. So that's why it's called tensile strain or radial tensile strain, because it is acting like this. But this strain that is coming at the top of the vertical top of the subject is vertical in nature, it's coming like this. So that's why it's called vertical strain. So tensile T, we will call it epsilon T, and vertical V, epsilon V. Strain is denoted by epsilon, that you know, I think. Right?
Yes, sir.
Okay. So now the design criteria. So the design criteria, as we already discussed in the very beginning of this class, that strain should be always higher or lower than the strength.
Sir, lower.
Lower, right? So see, strain should be lower. Now if I from strength, if I say strength gives me permissible strain, okay, and whatever is coming, it's generated strain. So permissible means if my material is this one, so if the strength is something or something, it will have some permissible limits. before failing that it can carry a strain of this much. Whether it can be tensile strain, it can be vertical strain, but it will have some threshold limit, right? So those threshold values, I will call it your permissible, and the generated is coming because of the wheels. Okay, it is getting generated. So this permissible should be always greater than the generated. So what kind of permissible strain? The horizontal tensile strain at the bottom of the bituminous layer. Okay, it should be always higher than the horizontal tensile strain at the bottom of the bituminous layer. So see this linear elastic theory, I will come in my next class, but by applying standard Excel law. So this is coming because of the load, and this is coming because of the material. Okay, because of the material or the layer properties. Okay. So what kind of material you are using, that you already know. So that material will have how much threshold limit, that you should be knowing. Then you test it whether the generated tensile strength is crossing that value or not. So if it is crossing, then what you should do? You should increase the thickness. Okay, you should increase the thickness. Then your generated will remain like generated will also get reduced, and this will also get increased. Understood?
Yes, sir.
Okay. So are you familiar with this formula?
Yes, sir. We might have got it in a design proposal.
Design, but you said you skipped design.
Yes, sir. Just for objective questions, we just looked at the formula, so we did not exactly know the procedure.
Okay, this is a very important formula. If you are preparing for GATE or any competitive exam, you should remember this formula. You should not get confused. Okay. Anyway, I can continue, but generally attention span is only for 45 minutes at undergraduate level. So I see many people leaving. So shall I continue or shall I stop? Nobody will say shall I should continue, but I will stop because this is again a new topic, design traffic. From that we will enter into the details of designing flexible pavement. But I want to know, are you like getting interested in this course?
Yes, sir.
Okay,
Yes, sir.
Yes, sir.
okay. This is a tricky question because I want to take an extra class tomorrow. If you are interested, because I need to complete my syllabus. So are you free? See, anyway, 16, right? Out of 16, also like 6 or 7 people are not interested. They are just running for the namesake. It happens like this. In my AC days, out of 100, because I don't take attendance, so always 30 people will be there, and I like interacting, I like teaching those 30 only because they are interested. So I assume that this 16, or I don't mind if 10, or I don't mind even 5 people are there, but those people should be interested. People should be interested in learning new things. Okay, so can I take a like class tomorrow? Because these lectures are being recorded. Okay, I have 3 systems. So one system you can see this is being recorded here. I'm using this system right here, and this system here I can see all of you. So I will record, I will upload all the lectures. So if you miss the lecture, no need to worry, you can watch the recordings. But if you allow me, I want to take class tomorrow.
Sir, tomorrow at the same time it should be fine, sir.
The same time, is it fine? Okay, all right. So because if you ask, because I don't want to ask in the Google Classroom, because some people will always object. They will not attend. They don't want to attend also, but they will object. So I think I can take a class. But will you be traveling tomorrow? Because you said after tomorrow you are.
Sir, I personally will be traveling, but I'll get there by 1 p.m. or so. So in the evening, most of us should be.
Okay. So anyone who is traveling, you have the raise hand option here on this platform. Out of the 16 people who are listening, 16 I think my four are from me only. So out of the 12 people who are listening, are you okay? Tomorrow at the same time?
Yes, sir.
Okay. Thank you. All right. So we'll continue from this design topic part, and tomorrow maybe you would like to keep your calculator with you because we'll solve together so that you will learn in a better way. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Okay. Bye.